And welcome everybody to our quarterly AGA SSSBA coordinated webinar series. You saw the list of things that are going to happen this year. For those of you that joined us last year, the first year we did it, welcome back. Today we're going to talk about essential bridge design resources. So what is our job? As an engineer or an owner, our job when we put a roadway in is to build this bridge over a creek or over another roadway or something like that. And so we're going to start with that. We're going to start by saying we need to design a 2-lane simple span bridge over this little creek maybe here, as you can see. And so when we start thinking about this, there's a lot of stuff that happens first, right? By the owner or the engineer, we got to decide how long it is for hydraulic opening and that type of thing. And we've decided it's going to be an 80-foot simple span composite steel girder bridge. We have 2 travel lanes. This is pretty high ADT, average daily traffic of 5,600. And we like to build our bridges with a 34-foot roadway width. And we like these Jersey barriers that are 1 foot, 3¼ inches wide. That's the service part of this bridge. That's what the public sees and drives on. We have our shoulders and we have our lanes. But the engineer now has to decide what goes under this to hold it up and meet all the specifications. We need a design for the bridge superstructure. Now, the SSSBA, quite a few years ago, 17 years ago, developed standard designs for short span bridges where we just came up and we designed bridges according to AASHTO from 20 feet to 140 feet for simple spans in 5-foot increments. We looked at 4 different girder spacing, 6, 7.5, 9, 10.5. And for each of these, the solution gives the steel girders, the shear stud and stiffener layouts, the welding and fabrication details, even the elastic bearings in the concrete deck design. And it's pretty easy to use. And we call this a preliminary design because, of course, we have these 4 discrete girder spacings, and you're going to put in what you really need, and you're going to have your own county or state details that you like using. But if we're designing this 80-foot bridge, eSPAN is going to give us 2 solutions in the I-type shapes, a rolled beam solution and a plate girder solution made out of 50 KSI. Now, the Alliance also has a lot of members that are part of the Alliance that are bridge manufacturers that build press brake tub girders and buried steel bridges, and those solutions are also given to you for you to consider. But we're going to talk about the I-shape, the rolled beam and the plate girder solution here. The program's pretty easy. It's free and it's pretty easy to use. You register and you get it. And here we're putting in the bridge span, 80 foot. 2 lanes, 34-foot roadway width. That's what we like. We like those parapets at 15¼ inches. And we like an overhang of about 2.5 feet. And once we put that in, that standard design is going to come out and it's going to say, hey, let's look at the rolled beam solution. And it recommends, let's consider 4 girders at 10.5-foot spacing with a 20-foot diaphragm spacing for our construction and that kind of stuff. And the beam that works for that, the rolled beam that works for that is a W36 by 210 that weighs 16.8 thousand pounds. There's a solution that we can place on the table next to other material types and talk to the fabricators and talk to the bidders and things like that to see which one is the most economical. It also gives us that plate girder solution. It also says 4 girders at 10'6", still a 20-foot diaphragm spacing. And then it optimizes our section, right? It has a singly symmetric section where we put a top plate of a 16 by 1. Bottom plate starts with that for a while, then goes to a 16 by 1/2, then goes back to the 16 by 1, and it has a 32 by 1/2 inch web. And it saves us some weight. We see this one only weighs 14.3 or 14.4 thousand pounds. And so now we have 2 steel solutions that we can put on the table and say, okay, which one should we bid or should we build? And so eSPAN will give us that preliminary design in just a matter of minutes so that we can look at the competitiveness of steel versus other types of bridges. So eSPAN 140, like I said, it's been around for about 15, 17 years. It's a web-based tool that gives us those preliminary designs for rolled beams and plate girders and press brake and buried bridges. I do want to mention there's also the National Steel Bridge Alliance. We're the Short Span Steel Bridge Alliance, but we are very closely related to the National Steel Bridge Alliance. And they have a program called LRFD Simon, which is an optimization program that is really good for continuous span bridges, where of course ours just does simple span. And you can also get that off of their website. That's also free after you register. So look into those two. And then the Alliance started a new effort back a couple of years ago to say, we can do better than a preliminary design. We could actually do more of an optimized design using Excel. And we came out with this eBEAM 140. And I'm going to talk about that one a little bit because it's fairly new. And this is the disclaimer sheet that you'll see when you first open it up. But it is for composite and non-composite simple span rolled section steel bridge designs. So I'm going to start by just kind of doing a little demonstration here. So let's say we have a 52-foot span. We need that simple span. We need 2 lanes, and we like 6 girders at about 5.5 because we're a county maybe, and an overhang of 15 inches with a little bit of barrier and a roadway width, a bridge width total of 30. Typical rural type bridge. We're only going to put one diaphragm in this thing right at the middle. That's minimizing the number of cross frame type things. This is going to be a corrugated metal deck with a gravel riding surface. And whoever designed this and built this assumes that that bridge is unbraced. The top compression flange is unbraced. We're going to change that a little bit later to show the power of this program. But right now, we're going to say it's unbraced. So we have that lateral torsional buckling stuff. No additional dead loads, no wearing surface since it's the gravel. We're going to put a little bit extra in there for the steel. We do want the deflection limit of L over 800. And for fatigue, we have an average daily truck traffic in a single lane of 200, which means we're in the fatigue 2 category or finite life. Now, this program also will do a user-defined vehicle, but we have none here. And we run this thing, and at this point, I would actually bring it up if I had a full hour, but since I'm sharing this with AGA, I'm not going to bring up the Excel file. But it tells us a W36 by 135, where the controlling performance ratio is the Strength 1 AASHTO 10th edition limit state. So let me talk about the program a little bit before we get a little bit deeper into that example. It does non-composite and composite design. It'll consider yield stress steels from 33 all the way up to 70, the 33, 36, because some states have some extra beams that counties can use that they can check. It's very variable in bridge layout. And diaphragm is variable along the span. We can use any decking, whether it's wood, the different types of wood decking, or a grid or a corrugated metal deck. It can do non-composite concrete if we're going to design something like that, or even composite concrete. And then one of its strengths is that, yes, it does the AASHTO HL93 loading, but you can also put in a state vehicle or a special vehicle, like here I'm saying a logging truck if we're in the Northeast or the Northwest, and it'll do the full design. And not many software programs will do that. So that diaphragm spacing is variable along the length with up to 7 unbraced lengths, which means we can do skewed bridges. It does not have to be symmetric. We can say the compression flange is braced during construction or unbraced, whether in the final state it's braced or unspaced. Of course, I said any decking. If it's composite, it has all sorts of variability in there, whether it's full depth or stay-in-place forms, a sacrificial surface. It'll do the shear connector design. We can put additional dead loads on there. We can do variable bridge railings, and the steel beams are individually considered in the dead load instead of just some conservative value. We can put a wearing surface on there, of course. So it'll do that vehicular loading with the AASHTO HL93 truck, the standard AASHTO 10 truck, but we can also put a user-defined vehicle in there, like a logging truck. And we can even dictate how we wanted to handle it, whether it's a strength 1 or a strength 2 with a different live load factor. We can have an optional lane load. We can say when that truck's on there, we only have that truck, so we can use single lane distribution factors. We can put our own impact factor on there. And then, of course, those live load distribution factors are important, and they're one of the hardest parts of designing a bridge, and it takes care of all of the different AASHTO requirements for that, whether it's an interior girder or an exterior girder, even with the rigid rotational analysis. And we have different live load factors, whether it's wood or concrete or corrugated metal deck and all that kind of stuff. You can also control what the program does. For instance, you can limit the span over depth ratio, and you can specify a minimum depth if we have certain diaphragms we like to use. You can say, here's my maximum depth because I have a clearance issue or an approach issue, and yes, I'm willing to spend a little extra money if I don't have to do approach work. Of course, we have W40s and 44s. Those are made by one producer, which means there's usually a premium on them. And so we can just say, yeah, we don't want to consider those, or yes, we do want to consider those. And of course, the deflection limit and some miscellaneous steel. And then, of course, it applies AASHTO 10, which has changed from AASHTO 9 in certain aspects, which has made it easier and better, more economical for steel bridges. And this is updated all the way to AASHTO 10. For fatigue, AASHTO 10 changed a little bit, significantly better for short span steel bridges. And it's either going to be a fatigue 1 or a fatigue 2 based on that average daily traffic in a single lane. And we can even say we have a variable life, that we want it to last 100 years instead of 75. So the program performs the dead and construction, which is important with composite construction, and live load analysis for each unbraced length. And then it checks the strength 1 or strength 2 and constructability design for each unbraced length. And of course, it checks that service 2 stress limit near the center line at the maximum moment. And then it checks the fatigue at the critical diaphragm location, where we assume that it's a connection plate for a diaphragm that's welded to the flange for a detail C prime. Then if it's composite, it'll do the composite design, which is AASHTO 10, which has changed significantly and has become more economical. So this Excel-based non-composite rolled beam design software that we use for this one, what it does is it determines all W shapes that meet the strength 1, 2, and service 2 and construction performance ratios. And then it reports out the corresponding fatigue performance ratios and the deflection performance ratio. And here it is for the example we did. For instance, the top one says a W36 by 135 meets strength 1, 2 in construction. It also meets fatigue because it's listed there. It also meets deflection. And that's the one we would pick, and it weighs 21.1 tons. But we could go down one and say, hey, we could save 3 inches of depth by adding 6 pounds per foot with a W33 by 141. Or if deflection is not critical at L over 800, we could go down 9 inches to a W27 by 146, which meets the strength and the fatigue. It doesn't quite meet the deflection, but the deflection is at L over 761 instead of L over 800. Most of us would say, well, that's close enough. So you have an option of what you can check. And that's one of the strengths of this program, is that now we can do all sorts of what-if questions. We can change diaphragm spacings. We can change other than the lightest weight solution and look at that 27 by 146. We can go to our yard and say, hey, we've got some of these 36 by 10 whatevers. Will they work? And all we have to do in that yellow box is put in a new section, and below it'll tell us whether it works and what are the performance ratios for all the different types of limit states. And on the right, we just have a list of all of them that meet the requirements. Then, of course, it gives us a design summary where all the superstructure design results specific to the limit states and unbraced lengths, etc., all that kind of stuff. Also gives us a dead load camber It gives us abutment reactions, cases for multi-lane bridges down there at the bottom, where, if we only have one lane, it's a lighter load, but there's a higher eccentricity from the center line. And if we have both lanes loaded, it's a higher load, but not as much eccentricity. And of course, if it's composite, it'll give us a strength and fatigue stud design. But these are all the results the engineer needs to verify the design. So now let's change that. Let's say, as a designer, I'm going to put little puddle welds on that corrugated metal deck to the top flange, so it's going to become braced. Or I'm going to put an extra diaphragm in there, and that's actually the first one we're going to look at. Here I say, instead of just one diaphragm in the middle, I'm going to have two diaphragms, so I have unbraced lengths of 19, 14, and 19. And on the left's the original design with just the one diaphragm. And on the right's the one where all I add is a diaphragm. And we save 5,400 pounds of steel because it goes down to a 33 by 118. But of course, I need the additional diaphragm. Or how about if we say, when we build this thing, we are going to attach it to the top flange. So my unbraced length is really 0 because of the corrugated metal decking. On the left's the original again, 36 by 135. And on the right is the one that is the least weight for the braced flange. And we see a W30 saving 6 inches and 116 saving whatever that is, 19 pounds per foot, or 6,000 pounds of steel saved. And I don't even have to add another diaphragm. Now, I do have the issue with the deflection. The deflection is L over 663. If that's okay, that's okay. If not, I'm going to go up to a little bit bigger section. Then the last one for this example, this 52-foot span corrugated metal deck gravel riding surface, is what if I use a logging truck? What if I have a logging truck requirement? Now, I didn't show the logging truck here, but we know they're heavy, 160 kips. We know they have lots of axles. And on the left is the original, and on the right is if we have the logging truck. And at the bottom, I have two cases. One is that logging truck is going to be on the bridge by itself. So I'm going to call it a strength 2 limit state, which means my live load factor is not 1.75, it's 1.35. No lane load, single lane distribution factors. If I consider it unbraced, it comes out to be a 36 by 150. Boom, I'm done. I've got the difference. It goes from a 36 by 135 up to a 36 by 150 because of that logging truck. But if I also say it's braced, like I did in the last example, it goes from a 36 by 135 down to a 33 by 130 because that bracing helps with lateral torsional buckling during construction and during the final state. Then, of course, I have to show a composite example. Here's one, 62-foot long, pretty much the same bridge, except I have a little wider spacing because it's composite. Little bigger overhang, barriers, roadway width still 28 foot, bridge width 31 foot, but I have an 8-inch structural depth. I have a 1/2-inch sacrificial surface on that, and I have a 2-inch haunch from the top of the web to the bottom of the deck. I'm using 2-inch stay-in-place forms, which weigh 15 pounds per square foot, and I'm going to use 7/8-inch shear studs. The rest of it, yes, I'm going to put a little wearing surface, a future wearing surface. I'm going to consider that. But now I have that construction load up here where I'm kind of wiggling my cursor. And that causes torque on the outside, which puts lateral flange bending into my external girder top and bottom flanges. And there are requirements for that in AASHTO. And so it's not, the compression flange is not braced during construction, but of course is afterwards. And this one I'm going to say I've got more truck traffic, so I'm in the fatigue life. And the answer comes out to be the same, just a coincidence, 36 by 135. But now fatigue controls the performance ratio at that stiffener location at 0.961. But it still gives us the top 10. It still lets us do what if questions, just like it does for the non-composite. For instance, I can go down. I can look at a W40. I can look at different. I can use that W33 and W instead of the W36 by 135. But now that 27 by 146, I don't meet fatigue and I don't meet deflection. So that's probably not one I want to consider. But I can look at any section I want to here and see what it does. And of course, it's going to give me all of that result stuff like it did before, so I can verify it as the engineer. It's going to give me the strength 1 or 2 design checks, performance ratios in each unbraced length. It's going to do the construction in each unbraced length with all of the lateral flange bending stuff that's part of AASHTO. And it's going to give me the dead load deflection so I can specify the cambers. Also gives us the nominal abutment reactions, just like the non-composite example did. But then now this one also does AASHTO 10, which I already said is going to be more economical than AASHTO 9 or previous, where it gives us an adequate singles, doubles, and triples pitch for the shear studs, for those 7 and 8-inch shear studs. It also gives us an estimate of how many studs it takes for the whole girder for that composite design under AASHTO 10. And so eBEAM 140 was released last fall, September 2025. It's free, just like eSPAN, just like Simon. And you can go to shortspansteelbridges.org or directly to the /eBEAM 140 and download it. It also has a user manual and examples that you can use to make sure you're using it right. So with that success, lots of people are using it, and it's going very well. There was the need for a plate girder simple span Excel design, and so we developed one of those, or it's developed, it's in review right now, and we're hoping to release that here in 2026. And it's very similar, but now it's plate girder design. And the issue with plate girders, of course, is there is an infinite number of solutions that'll work for a particular design. But if we say, hey, we want to target L over D, maybe 25, right? And it's going to check a little bit less than that, at that, plus 3 more. So it's going to look at 5 different web depths. And then it has a set of flanges it checks so that it does 5,100 possible design solutions for those 5 different web depths. And down here on the bottom right, it just lists from lightest to heaviest, all of them that work. And the weights on the far right. And on the left in the yellow, of course, as the engineer, we still have to be smart. We pick what we think we want to use. For instance, here it's a 13 by 3/4 top flange, a 38 by 1/2-inch web, and a 17 by 3/4 bottom flange. And then it'll do a very similar thing as it did for eBEAM. It'll check all the unbraced lengths. It'll check all the AASHTO design limits and let you know that this section works. Okay, so that's my part of this presentation, giving you three design resources that you can use with eBEAM and ePlate coming, and then Simon is a bigger program for more complicated structures. But I do want to end with this. We are the Short Span Steel Bridge Alliance. Our director is Dan Snyder. He's on the line, hopefully answering chat questions. But here's 5 things. Every Friday morning at 9:15 Eastern time, he sends out a newsletter that has more or less three things on it. And you should sign up for that, and you can do that on the website. You can find one of our alliance members, whether it's a traditional fabricator or a bridge manufacturer on there. We have the eSPAN and the eBEAM on there. And then on the right, we have a schedule of workshop webinar, which we like doing. We'll come out, won't cost you anything, and we'll work with you and maybe a local engineering organization to put on a workshop or a webinar series. So I really encourage you to visit shortspansteelbridges.org, see what there that can help you. So next I'm going to turn it over to Jeff to do the AGA part. Unfortunately, I need to leave, so I won't be able to answer live questions because I have another international webinar that's starting here at in about 30 minutes that I have to open up early. So, Jeff, I'm turning it over to you.
Awesome. Thank you so much, Dr. Barker. Really appreciate your expertise in this field. And like they said, reach out to SSSBA for some more information. But I do appreciate you taking the time out of your day to present. All right. My name is Jeff Cunningham. I am with the American Galvanizers Association. I will be presenting today on the AGA tools and resources, especially for hot dip galvanized steel and with a bridge specific focus. All right, so just a little bit about the AGA if you haven't heard about us. The American Galvanizers Association, we were established all the way back in 1933. So we're coming up on about 100 years we've been around. Galvanizing has been over, 150-year-old process and just continues to get better. We represent over 170 hot dip galvanizing plants in North America, Canada, US, and Mexico. We're um, expanding down to Latin America as well, and we represent over 75 companies with that. We are a free resource for North American specifiers. So architects, engineers, anybody working on a galvanized steel project, please do reach out to us, and we will help you out as much as possible. So we're a free resource, free customer service about anything galvanized. All right, so first I'm just going to kind of go over some of our main resources, kind of top level, and then we'll drill down a little bit more bridge specific stuff. Our website is kind of our bread and butter, galvanizeit.org. So if you want to galvanize something, you go to galvanizeit.org. It will give you everything you need right in one place. A galvanizer locator, it even lists their kettle size and what kind of stuff they do. You can put in a mile radius and get you in touch with them. Search function on our website is extremely powerful. So you just start typing in one small sentence or one small phrase, and you'll get a wealth of information. Knowledge base is our frequently asked questions. We have over 400 in there now. So chances are, if you had a question about galvanized steel, the answer is there. And the Dr. Galv articles are all from our Dr. Galv herself, and she is a absolute extremely knowledgeable when it comes to anything with galvanized steel. So chances are your questions will be asked there. Like I mentioned, the knowledge base, they're short form Q&A articles. So it's just organized by category, which makes it really simple and easy to find. It's mostly just, anything from small parts all the way to large structural, all the way to in use, touch up and repair, inspection, even about the hot dip galvanizing process, because a lot of architects, engineers, might not know the intricacies of the actual process of galvanized steel. They just know it gets dipped in zinc and sent on its way. And then they're just technical expertise tailored to the galvanizers as well. And then, when you're searching it, the public side is kind of, you get to hear from the galvanizers themselves. So on certain fabrications, you might have, certain stuff that, vent and drain holes that might need to be, fabricated into the design and stuff like that. All right, so we also have design considerations, design guide, and our design poster. So these are all design considerations that are all on our website. And it is just every kind of common fabrication, big and small, that gets galvanized a lot. Common products that might need a little bit extra venting or drainage. If you're working with asymmetrical parts, sometimes it's easier to put them together to make a symmetrical part so that it's more evenly heated and cooled when it goes into the bath. But this is all contained in all of these documents for you. So the design guide is actually a 30-page publication available to download for free. And it will go over, kind of split into sections. Very handy to have. And then our design poster is available to order, and it's just a poster size that you can put in your shop. And it just has those common fabrication, that might need just a little bit of extra thought involved when galvanizing. And then we just launched our new website a couple years ago. This is actually in conjunction with the Bipartisan Infrastructure Law Act, BIL, passed in 2021, but we're finally now seeing money actually kind of trickle down into these projects. We're seeing projects get started. So we decided to make a whole markets website, markets.galvanize.org. And this is highlighting hot tub galvanized projects within a market, product type, or state or province. So you can drill down by state. It gives information on the funding, where the funding's going, even some projects that are getting started within your state. You can also go market or product type. So maybe, bridge and highway. Then you can drill down and we put all these animations together that all the blue animation or all the blue parts in the animation are what can be galvanized steel with a lot of these infrastructure projects. And once again, you can click into it, drill in a little bit more, get some more information. But definitely, especially working with Bridge Highway, this is a great resource to have in the back of your pocket. Markets.galvanizeit.org. Here, I'll show you kind of what I was talking about with the animation here. So each one, and we have all these across, aviation, transportation, water, marine, simple environment, simple structures down to, fastener, small parts, all, are available, through these animations and stuff to learn more. All right, one of our most powerful tools, I'd say, is all of our zinc coating life predictor and our life cycle cost calculator. So these are actually off of real world data. So it's not accelerated salt spray testing or anything like that because when you salt spray galvanized steel, it doesn't accurately mimic the and it doesn't allow the zinc patina to form, which really extends the life of that galvanized steel. So this is off of all real world data. We collected it, various environments, statistical methods, neural network technology, and extensive worldwide corrosion database. We worked in conjunction with Dr. Gregory Zhang, and we use this to develop the time to first maintenance chart and the whole zinc coating life predictor. So when you have your parameters of your project and stuff, you can put it in here, and it will give you a guide to the time to first maintenance. So here is a time to first maintenance chart that is defined in 5 different atmospheric categories, and with the full zinc coating life predictor once again off of real world data. No salt spray testing, no accelerated testing. So if you notice, average of thickness in zinc and mils is going to be on your x-axis, and y is time to first maintenance in years. Now, time to first maintenance is defined as 5% rusting of the steel surface. So still very minimal rusting of the steel surface, but might be time to get out there and do a little bit of touch-up and repair. Per ASTM standards, it requires at least 3.9 mils of zinc on any structural piece. So more like, 4 to 5 to 6 even mils most of the time, but 4 mils is a good estimate for any hot tip galvanizing piece. You can see if we built in industrial environments, which is pretty corrosive and harsh, we're still looking 75 years before we get time to first maintenance. And that is off of real world data. And, we might get out there at year 75 and we might not see 5% rusting of the steel surface. Or, it might have hit its end of life, and then we can strip and recycle 100% of galvanized steel, both zinc and the iron are 100% recyclable without any loss of properties. So truly a cradle to cradle material. All right, so a lot of times you're building a bridge and you're dealing with soil. Whether it be on one side of the road, you might be dealing with the clay-like, silty soil. The other side might be more rocky, arid. So it's kind of hard to predict. So we have kind of taken some of the guesswork out of it for you. When working with galvanized steel and in soil, we've developed these soil charts for you. Once again, they're all available on our website. This entire PDF has, every time you see a little mouse icon, that's a clickable link, usually to a PDF, a publication, case study, or a link on our website. So just keep that in mind. But with dealing with soil, these charts are actually estimating the full service life. So not just the time to first maintenance, but full service life is defined as the time to necessary part replacement. So that's total zinc consumption plus 25%. So that's a lot longer than just the time to first maintenance. So keep that in mind. Anything in the green is more favorable. Anything in the red is less favorable, obviously. Good rule of thumb is always 4 mils of zinc is a good estimate. And then when you know your chloride level and pH level and moisture content of your soil, you can figure out what chart you're working on. So let's say we have a low chloride and a high pH, we'd be on chart number 3. So once again, 4 mils, we're looking about, yeah, over 60, 70 years in less favorable situation. So once again, this is a great rule of or this great thing to have, another resource in your back pocket when dealing with, galvanized steel within soil. I mentioned earlier that life cycle cost calculator kind of goes along with the zinc coating life predictor. And this life cycle cost calculator is just the total cost throughout the project life. So it's, start, initial cost, all the way touch up and repair, maintenance costs, and it also includes time of value, so interest and inflation. When you run a lot of these calculations, most of the time, hot tip galvanizing initial cost is its full life cycle cost because it lasts so long in some of these harsh environments and doesn't need to be touched up and repair every 8 to 10 years like paint or some other coatings. Life cycle cost calculator is to ASTM A1068. I highly recommend everybody go ahead and try one of these. It's pretty cool. You're gonna put it in your project parameters, and then it pits you out a nice cost comparison report. You can even download it as a PDF. You can even put your email and send it to yourself or send it to somebody if you're doing it, comparing job notes and stuff like that. So LCC, you have your square foot, typical mix of sizes and shapes, where you're building at, different environments and stuff like that. So once you put in all your inputs, then you get this nice report, prints it out, and oftentimes you will see that galvanized steel, that the initial cost is going to be the life cycle cost because you don't have to maintain it or touch up and repair for, 50, 60, 70 years in most cases. Yeah, so we have a lot of times people are like, well, what about these giant, steel beams or girders that are too big to fit in the kettle, over 40 feet long or something like that. Well, what we have is we actually can do a progressive dip. It's dipping one side of the piece, flipping it around, dipping the other side of the piece. Now that it is, a little bit more involved by the galvanizer. I refer to say, I falsely call it double dipping, but it's not really double dipping because you're just dipping one half and then dipping the other half. So it's just a little bit longer process. There are some controls for the galvanizer. And you also want to make sure that it's going to fit in the kettle. So we have progressive dip charts, and we also have a progressive dip calculator to take the guesswork out of it. So you put in your what your parameters are of what pieces you're working with and the kettle size, and then it can tell you what's going to fit, how it's going to fit, and if you need to do anything else. So it depends on kettle dimensions, the part dimension, and material handling capability. So sometimes it's either laying it out or it's hoisted through cranes, overhead stuff. So you just want to make sure to have that additional discussion with your galvanizer to say, hey, got some large pieces. They've probably done progressive dips in the past, so they can kind of lean or point you in the right direction and stuff like that. A lot of times there is going to be an overlap line, just where it kind of gets double dipped in the middle because you're dipping one side, flip it over, dip the other. So there might be those overlap lines that are a little bit more rough. It could be a little bit uneven heating because you're taking one part all the way up to 830 degrees Fahrenheit, where the other part just stays ambient temperature. So it does increase susceptible to warpage. You're just you're putting a lot of stress onto that steel. So if there's any inherent stresses within that steel already, they're going to be released by a hot and cold on the same thing. So once again, just have that additional discussion with your galvanizer, and we can help out too, or pop on our website for progressive dipping resources. All right, our YouTube channel is chock full. We actually just finished up an Inside the Blueprint. Hot Tip Galvanized Steel is featured on Inside the Blueprint and Bloomberg. a TV show where they kind of go around and highlight different businesses. Very cool segment, kind of gives you an overview of galvanizing and how far it's come. But we also have different playlists. So we have a touch up and repair playlist. Goes over every acceptable material to use to touch up and repair galvanized steel, when is an appropriate time to use it, and how to properly apply it. So they're just simple 2, 3 minute long videos, and they go over how to do all the different touch up and repair materials. We have a bunch of bridge projects that are at least 10 years in service, and we go out and interview the architects and engineers, kind of why they chose galvanized steel, what benefits have they seen over the last 10 years of service. Really cool projects in there, especially the Riviera Coutron Gras Bridge. It was a bridge spent 15 years in New Hampshire, very harsh climate, and then it was actually shipped and all the way down to Haiti to help a rebuild after a hurricane. And without any new steel or anything, it was completely reused. After 15 years in, New Hampshire's harsh weather, it was able to reuse that. Great story there. Buffalo Creek Bridge. I think everybody had probably heard of that one, but definitely worth checking out our YouTube channel. We also have an appearance series, which goes over the different appearances of galvanized steel. We get that question a lot, like, can I request the spangle, or is it going to be shiny or dull? It'll all eventually weather out to matte gray, but we have some information on appearance series of initial appearance of galvanized steel. All right, inspection. We have a wealth of information on inspection. A lot of times we have to go inspect the bridges that we build. So usually galvanizing is just conformance to specification for ASTM. Usually a visual inspection with the naked eye, just making sure there's no bare spots. Coating thickness can be checked by a magnetic thickness gauge. And then we have a ton of information. We have a whole PDF, a publication on inspecting hot dip galvanized steel products. We have an inspection online course. It's pretty cool. You get a certificate, obviously, and then your name listed on our inspect-in listing. And then we have a free inspection app. Once you download that app, it doesn't require any service. So it just is on your phone. So if you're out in the boonies, you can have a full access to our app, and it gives a clear visual guide to surface conditions of galvanized steel. All right, publications, another great resource for everybody. I have over 40 different pubs available, all download for free PDFs online. Some good ones that I highlighted out there are we have a bridge specific publications, like a galvanized steel bridges, a practical design guide. We have a ton of stuff on reinforcing steel, so rebar. Duplex system, which is paint or powder coat over galvanized steel. A lot of times we do that in harsher climates, or maybe it's right over a river or something. And then inspection of products, and then sustainable design as well. All right, and then galvanizing seminars. We obviously do these 2 to 4 times a month, sometimes even more. You can get every time we always update galvanizing.org/webinar. So that's the one website. If you just bookmark that, we will always have new listings available there. And we have on-demand courses, over 12 courses available, and then lunch and learns, just like SSSBA, we will come to your office and provide lunch and give you a couple credits for PDHs. And we're also offering plant tours. So if you have a galvanizer in your area, you can go over and tour their plant and get a credit for AIA and RCEP continuing education. All right, I'm just going to highlight a couple of our partnering orgs, more resources for everybody, especially in the bridge market. Obviously, the SSSBA, they have presented first. They're targeting bridges up to 140 feet, hence the eSPAN 140. Galvanizing is kind of their preferred solution, but they deal with all different types of bridges, like Dr. Barker said, composite, metal, all that. We have a rebar focus group. It's galvanizedrebar.com, and you can join there. It's dedicated just to galvanized rebar information. So performance, mechanical properties, field handling. standards, case studies, publications, and FAQs all in one place for you. So if you're dealing with a lot of concrete and rebar, I'd highly check out galvanizedrebar.com because when you galvanize rebar, it actually prevents sprawling, cracking, outgassing. It protects the concrete and it has a better bond strength than black bar as well. We offer a full 1 hour seminar on reinforced galvanized steel. And then, of course, bridge resources. We have an increasing market share for the uncoated weathering steel. So a lot of times, weathering steel is a product from the 80s, and we've seen now weathering steel was marketed as good or better than galvanized steel, but now we're seeing some of the uncoated weathering steel bridges fail or need critical touch up and repairs. So we put out a bridge washing calculator that is now available on our website. And then this demonstrates the maintenance cost for unweathered or weathering steel versus, galvanized steel or even paint or powder coat. Because they're marketing as maintenance or no maintenance, kind of like galvanized steel, but they have to wash these bridges because, especially with a lot of chlorides or road salts, can be pretty corrosive for weathering steel. So we have a bridge washing calculator available now. It kind of, adds in another layer, another factor to think about when specifying between weathering steel and galvanized steel. So definitely check that out. And then we just put out our bridge design guide. This is in English. Hopefully we'll get one in Spanish as well. But this is all about hot tip galvanizing bridge design guide. It is a heavy, heavy technical um, um, publication. I believe it comes in almost 30 pages long as well. So definitely check all those out on our website for free. All right. I like to mention because it's kind of transmission to distribution. Obviously, sometimes bridge is involved with this, but we actually have a second pillar of our AGA is the Clean Energy Steel Construction Center. This is a AGA and IZA, International Zinc Association collaboration group. And we are in everything from, solar transmission to wind power, nuclear, hydropower, hydrogen, everything like that. So the mission for them is really to, champion the use of American-made or North American-made steel across the clean energy spectrum. They do member outreach, take advantage of IRAs, and then the simplified supply chain. And then, which is huge for you guys as well, is foreign versus domestic. So steel versus soil corrosion and race stuff like that. So definitely worth checking out. Their website is cescenter.com. Yeah, just a little bit more information on what they do. But in summary, I just appreciate the time to present, and galvanized steel bridges are definitely a way to preserve your bridge and make sure that it lasts over 100 years in some environments. A great way to if you're doing a concrete bridge, a great way to lengthen the life of that is to use a reinforcement steel. And then anytime you're wondering about specifying hot tip galvanizing, your first call should be the American Galvanizers Association, and or pop on our website and find out some more information there.